In the last 6.5 years with MLC, my areas of focus have largely been on SOLIDWORKS performance and simulation tools. So I've felt pretty fortunate to see SOLIDWORKS continually investing resources, particularly heavy in these two areas. When looking at the capabilities of simulation, you will again see both improvements to the ease of use of the toolset, as well as powerful behind-the-scenes performance gains. Take for instance this corner mount assembly simulation, where I've used a fixed hinge and bearing loads to represent excluded components. To reduce the calculation requirements, I'm able to set just the hardware components to use a draft quality mesh while keeping a high quality for my components of interest. I'm using a global mesh here without local refinement, and you can see the mesh and the stress results, they look really nice. But more than that, they were fast to generate. In 2021, we now have support for multi-core processing of contacts and available in SimPro and Premium, multi-core meshing, allowing me to run a study like this in less than 20 seconds. Now, I didn't idealize this assembly with coincident faces, but my contact setup was still extremely fast. And this is because new properties for bonded and contact interactions specify gap and stabilization regions, which kind of automates the contact setup even for models with imperfect geometries. For example, with this new property, there's different clearances here between the bolt, the nut, and the plate, but they're automatically recognized, meaning I'm not troubleshooting a model as unstable message, or looking at this comparison here, retuning some inaccurate results where a contact wouldn't have even been picked up in the past due to that gap. The results and interactions are actually more accurate as well. For contact interactions with cylindrical, spherical, and conical geometries, correction factors are now integrated. And for bonded interactions, improved accuracy is also built in for incompatible meshes, a technology that's borrowed from Abacus. This enables faster and more complete meshing where interacting components can't easily share nodes. But if you're worried about the mesh, new tools to check the quality of a mesh are available. These poor elements here are automatically isolated, so they're easy to find, and there's even a mesh helper to use to further automate mesh refinement and local meshes if necessary. Of course, solver selection is important to speed, and so the automatic algorithm has been optimized to better account for a huge variety of variables so you get the best run for your specific computer and your specific setup. For you experienced users out there who have a favorite solver, you're actually going to recognize a terminology update that's throughout the interface, especially when it comes to component contacts, or what are now called interactions, to match up with just the conventional industry terminology. I just mentioned a technology borrowed from Abacus, the ability to have accurate bonded contact calculations in areas with an incompatible mesh. This is because Dassault Systems owns both Abacus and SOLIDWORKS, and we're simply benefiting from the technology share. If high-end tools like Abacus pique your interest, you should be aware that there is an avenue to take your SOLIDWORKS simulations to this level through the 3D experience. By now, I'm sure you've heard of the 3D experience. It's not the Jimi Hendrix experience, and unlike the Joe Rogan experience, the best place to check it out is on our YouTube channel, where I've recorded a 15-minute video over this and other platform tools. I'm talking about a range of mesh element types, automatic contact detection, the Abacus nonlinear and explicit dynamic solvers, and the power of cloud computing. So please subscribe to my YouTube channel. We've got the username MLC CAD Systems.